Today's video where we are going to be discussing or talking about the teacher's guide on O-level and A-level new curriculum physics practicals, and the facilitator is none other than teacher Hooke William. We may both be aware that the National Curriculum Development Center did some changes in our curriculum, and in particular we have got some new changes. Currently we have new curriculum in O-level and also new curriculum that started this year 2025 in Senior 5 A-level. So many people have been confused, both students and some teachers, on how to go about the physics practicals, and that is the reason why I have made you this guide today. Without wasting a lot of time, I would like to let you know that in this video I shall be looking at the physics practicals, that is in particular O and A level, and I'm going to be talking about majorly the part how to deal with variables in the following experiments: the mechanics experiments, optics or light experiments, and then the electricity experiments. I know by the end of the video you may be interested in getting some more details or getting to know more about this, and that's why if you want to always get the lessons, you can visit our YouTube channel, that is teacher William or Hooke William. You'll find it there, a variety of lessons in form of videos in the area of physics. So far, with time we shall keep on adding even others in other science subjects, or you can as well get a physics practical workbook, which is in the names of the author is none other than myself, and it has a variety of physics scenario items, the guide on how to conduct a physics practical. It guides on a number of things: significant figures, table of results, graph, and all that. You can name it. There are even worked examples that guides both teachers and learners on how to conduct a physics practical lesson. You can as well get me on WhatsApp on the number 0751 40 71 58, or a direct phone call on the number 784 620 920. You can as well email us on that email, ahebawilliam.welka@gmail.com. So we shall be able to get in touch, and maybe for any details or information that you may need, you may be wanting to supplement, to inquire, we can be in touch there and we discuss. So let's dive into the mechanics experiments. And under the mechanics experiments, I will in particular just highlight because I already know majority of the teachers or students, they already have ideas about this. I'll just be highlighting, like I told you, basically on how to get to deal with the variables, and then how to conduct the practical. So I'll give a hint on acceleration due to gravity in that area, the principle of moments, the mass density of a body or a liquid, then elasticity and Hooke's law. I believe by the time I finish giving a hint on those, anyone will be able to deal with any other area in mechanics. When it comes to optics, I'll just throw a hint on laws of reflection, that is plane mirrors, a refractive index of a glass block, focal length of a concave and the convex lenses. Focal length of concave mirror, then focal length of a convex lens. I'll also throw some light or hint on the electricity experiments, that is resistance of a resistor, internal resistance of a dry cell, EMF of a dry cell, and resistivity of a bare wire or resistance per meter for a bare wire. I believe even if I just give a hint on a few of those, anyone, you will be able to deal with others in that same field. Now let's start with the mechanics experiments. Now, under mechanics experiments, let's say you're interested in dealing an experiment to determine acceleration due to gravity, or an item is requiring a student to investigate on the acceleration due to gravity. Let's say the student is to use a spring. So what is most important is to always get to know the theory behind these experiments. It is very, very important. For example, if you're using a spring, from the theory part of it, you know that periodic time relates with extension by this expression, which is the periodic time. Periodic time is a square root of extension of acceleration due to gravity. It is 2 pi square root of extension of acceleration due to gravity, of which when we remove the square root, it squares. We square on both sides and we have periodic time squared equal to 4 pi squared over g extension. Now what we do is that I had already expressed this equation in the form of which is an equation of a line, because normally when we plot our graphs we expect them to come out as straight lines. So why is it important before you do experiment to first do this? One, you're planning to know your dependent variable and your independent variable. In this case, your dependent may be periodic time, then the independent being extension. So you're planning, you're getting to know that your periodic time will be on the y-axis, like you see on the equation of a straight line. Periodic time squared is on the y-axis, extension is in the position of x-axis. Then this part here is now in the position of the gradient m. Okay, we don't have intercept here because we take it under ideal situations it may be 0. That's why it is not appearing here. So we realize that if we express our equation in that format and we plot periodic time squared, I believe by this level you know how to get the periodic time, whereby you may be having time for, let's say, 10 oscillations or 20 oscillations, and then you get the period for one oscillation, time for one oscillation, that is capital T period. Then you square it. That is what we are having here. So I don't want to dive into those details of the experiment, which I believe majority may already be having idea about. So once we have it in that format, now you already know your variables, periodic time and extension. Then the main question should always be, how are you going to get what you're looking for? So in this case, you're looking for acceleration due to gravity. But we see from the theory bit and our equation, acceleration due to gravity is appearing with this whole thing, which is in the position of slope. So which we conclude that if we plot our graph of t squared against extension, we see that our slope will be 4 pi squared over g, because we've said this is what is in the position for slope or gradient. Okay, so if I already have a value from the graph, which is slope, I've calculated it from the graph, then 4 pi, I can get it. So it means I will be able to get my acceleration due to gravity by doing here the cross multiplication, then g goes here and slope comes down. I'll be able to get the acceleration due to gravity. So that is how one can get to know, or how one gets to know how to get the acceleration due to gravity using a spring. Another one may want to use a pendulum bob. Still, the expression theory part of it is this, like I had told you, similar expressions, and periodic time is related to length and acceleration due to gravity by this expression. So this is the length of the pendulum bob, remember, and I need to first express it in form of an equation of a line. And of course, when I express it in that format, you can see t squared, because I have squared now on both sides, that t squared is going to be 4 pi squared L over g. So I put g here and I end up with that expression, which is in form of y is equal to m x. So it means the whole of this part here will be the gradient, and therefore one will be able to get the acceleration due to gravity in the same way as you had gotten it this side. So that is how one can get acceleration due to gravity, or how one can carry out an experiment determining acceleration due to gravity using either a spring or a pendulum bob. The theory behind the experiment is the number one thing that you shouldn't forget. If we are to look at the case whereby we are looking at like the principle of moments, for example, let's say you have a setup like that, and under the principle of moments, maybe you are interested in finding, let's say, the mass or the weight, W2, for example. There is a mass given to it, is not known. You want to look for it, maybe mass of a bottle, mass of a Nile, anything that is not known, and then you want to do it. Remember the theory behind this is principle of moments, and what does it say? Sum of clockwise equals sum of anti-clockwise. Which moments are causing clockwise? W2 causes a clockwise rotation, W1 causes anti-clockwise rotation. So we know the moment is force times the distance, so it will be W2, which is our clockwise moment, W2 times the distance from the pivot, being equal to W1 times the distance from the pivot. And if we go on to express that this expression in form of an equation of a line, I can have W2 divided here on both sides, and I will have D2 being equal to W1 over W2 D1. And now you see that is now in format of our equation of a straight line, whereby it is a y equal to mx plus c. Now D2 will be our y on y-axis, D1 will be on the x-axis, meaning the gradient is going to be what? Weight 1 over weight 2. Now remember, weight 1 may be a known mass, let's say 100 gram mass. Weight 2 may be unknown, you get? So you're able now, you see, you'll be able to vary these D2 and D1, and of course in most cases D1 will be your independent, meaning you're going to set, when you place it at, let's say, 10 centimeters from the pivot, what happens? How much do you need to vary this so that it balances? You change again, you see how much do you need to change, meaning you keep, for every D1 you're getting D2, every D1 you're getting D2, and like that you're having several values that can be plotted. So from there we see we can be able to get our slope, which will be W1 over W2. Therefore, once you know the slope value, you'll be able to get W2, which is weight 2 that you did not know, from W1 divided by slope, and you can be able to calculate the mass. Remember now, weight is mass times acceleration due to gravity. Now once you have known the weight, meaning you'll be able to get the mass m2. Okay, so that's how you can determine the mass or the unknown mass of a given body using the principle of moments, the theory behind it, and how you can proceed about it. If we look at if we have a quick look at mass, density, volume of a given body, for example, density of a liquid, we know from our theory, density is given by what? Mass over volume, correct? So if I rearrange, I do cross multiplication, I'll have V coming here, 1 over, which will be volume is equal to mass over density. And I see that is already in the form of equation of a straight line, y is equal to mx plus c, which is 0 in this case. So it means if I vary my volume and I measure the corresponding mass, I'll have several values of volume and mass. I can plot them, and then the slope of that graph will be the 1 out of density. So meaning I'll be able to get density from 1 out of slope. So that is how you can determine density, mass, density, and volume using that formula of density. For Hooke's law, you now already know, suppose I'm supposed to determine the force constant of a spring, I will just use the normal formula, which is the force is equal to Ke, force, which is the weights that I'll be adding on the spring, and E are the extensions produced by those weights. So I see this is, if I replace weight with the masses, that will be mg is equal to Ke. implying that if I want to remain with only mass here, mass will be equal to k over g e. And now I know for every mass I suspend, I will determine its extension. So when I plot, I can see that is the equation of a straight line, y mx plus c, and my slope will be k over g. So if I want acceleration due to gravity, or if I want, the force constant, k will be equal to what? To g times s, acceleration due to gravity, times the slope. So I will have determined my force constant of the spring. Now let's take a quick look to about optics. If we look at optics, for example, laws of reflection, plane mirrors. In plane mirrors, maybe an experiment, a learner is required to investigate the law of reflection or to prove them in any way. We already know theoretically the angle of incidence is equal to angle of reflection. And if you just rearrange, starting with the angle of reflection, you see there is a one here which is hidden, okay? And that is in form of an equation of a straight line. So we see that if we plot our angle r on the y-axis against I on the x-axis, the slope we expect it to get, it will be 1, or almost 1. And once it is that, then it verifies that the angle of incidence will always be equal to the angle of what? Of reflection. So theoretically, that's how one can do it. You can as well use it to prove that in plane mirrors, the image distance is equal to object distance, theory. And still, you know, there is a hidden one there, which is in the position for slope. And once the slope is almost 1, that proves to us that the angle of incidence is, the image distance is equal to what? The object distance. So that is about plane mirrors. I can have a quick hint on refractive index of a glass block. We know from Snell's law, theoretically it concludes like the refractive index in medium where the light is coming from times sine of the angle in that medium will be equal to refractive index of the medium where light is going times sine of the angle in that. Now in this case, if it is a glass block, considering one of the boundaries, most especially if it is coming from light entering glass, then n1 is for air, which we consider to be 1, and n2 will be for glass, so which will be in this format. Now if I am interested in determining refractive index of glass, of course now I know this equation is already arranged in form of a equation of a straight line where this is y, this is m, this is x. So meaning I'll plot sine I against sine r, then the slope will be what? The slope will be my refractive index, ng. So that is about refractive index. When we look at the focal length for concave mirror and a convex lens, because they all use mirror formula, this is where majority of the people get confused. From 1 over f equal to 1 over v plus 1 over u, you can always take any root. One person can want to plot 1 over u against 1 over v. Of course, when you rearrange, you realize that when 1 over v goes the other side, it will take a negative sign, okay? Or you may want to plot 1 over v against, so meaning when you take 1 over u the other side, it becomes a negative sign. We see in both cases they are all appearing in the form of equation of a straight line, where 1 over u is y, m is negative 1, x is 1 over v, and c is 1 over f, implying that if you plot 1 over u against 1 over v, or 1 over v against 1 over u, 1, the slope will be negative. 2, you see that your intercept, the intercept on that axis gives you 1 over f. So you'll be able to determine the focal length from the intercept on either of the axes. So meaning for you to get focal length, you'll just do the cross multiplication and you get a focal length, okay? Some other people prefer using the LCM, taking the LCM VU. So when you simplify, you have up u plus v, down uv. And if we cross multiply to make it linear, we have it that way. So we are having here uv, u plus v remaining here, uv going this side, so you're having u plus v is equal to 1 over f uv, meaning if I plot u plus v against uv, we see that is in the form of, this is y, uv is x axis, so 1 over f is in whose position? Good, in the position for slope. So it means my slope will be 1 over f, meaning I can get f by dividing 1 with the slope. Alternatively, you can as well, another person may say, me, I'm plotting uv against u plus v, meaning now you have to take f the other side. So you see f is now in which position? You see that f is in the position for slope. So still from that angle, that this is y, this is m, this is x, you see that f is in the position for slope. Okay, and now when we come to electricity experiments, if we look at resistance of a resistor, we know from Ohm's law, V is equal to current times resistance, which is V is voltage. So if you just rearrange, since current and resistance and voltage are varying, then it means that resistance is remaining constant. So R here is in brackets. So from Y equal to mx, we see that from our graph, the resistance of the resistor will be the slope, isn't it? Yes, good. Or another person may want to say, me, I want to plot current against voltage instead of voltage against current. Okay, when we rearrange and we start with I, meaning we divide by R both sides, and we shall have I is equal to 1 out of R V. Still y equal to mx. We see 1 over R is in the position for slope, so it means that slope will be 1 over R. Therefore, if one wants resistance of that resistor, it will be 1 out of slope. That's how you can determine resistance of a resistor in a circuit. I will not go deep into how you'll connect and what. Like I told you, if you want to have more detail on that, you can get yourself the practical workbook, and all those details are in there. When it comes to let's say internal resistance and of a dry cell and maybe EMF, suppose your circuit is connected in this way. Always in electricity experiments, we tend to connect the voltmeter across the component whose voltage we are interested in, or the one we are interested in. If it was a resistor, I'd connect it across a resistor. This would be a resistor. If it is a dry cell, now I'm connecting it across a dry cell. So we know the experiment, or theoretically, we know voltage is equal to, the voltage across here will be equal to negative Ri plus E. Now this is in form of the equation of a straight line, which is y equal to mx plus c. V is the potential difference across this dry cell. Negative R is the gradient. I is the current, which is x-axis. Then plus E, which is the EMF of the dry cell. So, of course, I know this. If a learner is doing an experiment, we'll determine it before doing the experiment. We'll measure it before doing the experiment. So, we see that if a learner plots V against I for a dry cell, of course, you'll be varying using a rheostat. You can see that the slope of that graph will be the internal resistance of the dry cell. Okay, so it is negative because it will be a negative slope. We already have the idea. Suppose we want to get also the EMF of the dry cell. We see that the EMF will be got from the intercept on the V axis. Okay, V will be on the Y axis, so the intercept, because this is in the position of C, intercept. Okay, that will be the EMF of the dry cell. And just like that, a learner will be able to carry out an experiment and determine the unknown variable or quantity. In summary, one thing that I want to emphasize is that always let us help these learners get to know the theory behind these experiments. And before you attempt any practical, start by recalling the theory behind, because without it, you may not know the variables you're going to deal with, and how you can deal with them. Okay, then we should use those that theory to generate the equations that help us get independent and dependent variables, and we express those equations in form of an equation of a straight line, so that we are able to see how shall we get the quantity that we need. Shall we get it using slope, or shall we get it using intercept? If it is slope, how is the expression? Okay, so that we get them. Let's not encourage learners to cram, but we help them understand the idea behind. So for further details or consultations or supplements, like I said earlier, get us on WhatsApp 751 40 71 58, or call 784 620 You can as well email us on hebowilliam.welker@gmail.com. And just like that, I hope you learn a thing or two from this video. Otherwise, subscribe to the channel, like it, and comment. I will be taking your comments and your advice. Be blessed.